In the previous section, for everyone introduced the concept of artificial intelligence technical field and application field. So, in this section, we'll introduce Huawei's artificial intelligence development strategy to everyone. Next, let's take a look at Huawei's full-stack, full-scenario AI. Intelligent solutions. What does full-stack refer to? Here we can see that it includes our chips, chip enablement, and framework to top-level application development. The entire process is supported by Huawei's related technology. Provide support. First, we can see from the top level. Using the ModelArts platform can develop some AI applications. At the same time, application development is inseparable from some of our AI. Developed framework. This is MindSpore. It is benchmarked against what we commonly use now. Deep learning frameworks such as TensorFlow, PyTorch, and Paddle are used. Then we have chips enabling us to lean towards the lower end. CANN can provide us with chip operator libraries and highly automated operator development tools. The bottom layer is the processor we mentioned, Ascend. It is a series of Ascend processor chips based on a unified and scalable architecture. Next, let's take a look at the second keyword and the scenes it encompasses in the entire scenario. In fact, it includes the deployment environments of public cloud, private cloud, various edge computing, IoT industry terminals, and consumer terminals at the edge. So let's take a look from top to bottom at the core components involved in the full-stack direction. First of all, it's our ModelArts full-cycle AI workflow. From this diagram, we can see that the entire ModelArts platform mainly consists of 5 major modules: AI data framework, algorithm development, training, deployment, and market. First, let's take a look at the data framework processed by AI. This layer is a step where we need to process data when developing AI applications in the early stage. After collecting and processing the data, we need to choose the appropriate algorithm. Here in algorithm development, we will see that ModelArts provides us with some mainstream framework development environments that are ready to use out of the box. At the same time, there will be a dedicated model library to help us simplify model development. At the same time, in this algorithm development, there are some pre-built model algorithms that help us directly call the algorithms. We don't need to implement it from scratch. In this training module, we will see that it supports distributed value group acceleration. They greatly saved us training time. At the same time, it also provides fully automatic learning. So we don't need to write any code to help us automatically build such an AI training model. The well-trained model needs to be deployed next. Here it supports one-click deployment of edge-side cloud. That means we can deploy online from various platforms. It will also support our deep reasoning. Regarding this module on the market, it's like some app stores or marketplaces that we all use on our mobile phones. This platform provides us with some models of AI. Everyone can search in this market to find out if it is the application model they need. Communication and transactions can be conducted through this module in the market. We can see that the entire ModelArts platform enables us to achieve end-to-end visualized management. The version control of some data annotations can be traced in various modules of ours. Different versions of iterations can be clearly marked. Next, there is another topic about our AI computing framework, MindSpore. MindSpore provides automated transformation capabilities. Some senior algorithm engineers and data scientists for our data modeling and problem solving. Just a few simple descriptions are needed to run our algorithm on some of our AI computing nodes. The MindSpore framework supports adaptive independent deployment for various scenarios, scalable to large or small scales. It will also support our deep processors. It can also support processors like GPU, CPU, and so on. The next layer leads us to the level of our CANN chip in the HCIA-AI direction. This layer represents our operator library and some automated operator development tools. It can optimize our development efficiency, and it provides us with a deeply optimized universal operator library and a rich API interface. By combining these, we can enhance the computing power of our deep-level chips to the maximum. Here we will see the fusion engine in the CANN layer. In addition, we have our operator TBE operator development tool, CCE operator library, and CCE compiler for its compilation. These modules form a group. Next, let's take a look at the composition of the Ascend 310 processor and its DaVinci core. In this diagram, we can visually see some of its computational units. When we look at the DaVinci core, its main advantage is reflected in our computing units. Here we have 3 dedicated operation queues for matrix operations, vector operations, and scalar operations. Meanwhile, our AI processor also contains an ARM CPU. Through this comparison chart, we can clearly see the 2 chips of our Ascend processor. One is Ascend 310, mainly used for our inference. The Ascend 910 is mainly used for our training scenarios. Let's take a look at the artificial intelligence computing platform powered by Ascend processors. Correspondingly, these are the products that our Atlas specializes in, focusing on artificial intelligence computing. From the top floor, we can see some related edge platforms and our deep learning platform. It can perform functions such as dataset modeling, pre-processing, and so on. At the framework level, it integrates deep learning frameworks like MindSpore that we introduced earlier. In the middle enable layer chip enable layer, we can see the optimization provided by these graph engines. There are operator libraries, acceleration libraries, communication libraries, and other tools help us better utilize our Ascend computing power. In the hardware devices at the bottom layer, we will see different products of Atlas here. They also have different main trial usage scenarios. Here is an application case where our Atlas 200 acceleration module is applied to the garbage decomposition of our robotic arm. So China produces over 4 billion tons of household waste annually. The workload of garbage classification is extremely huge. At the same time, it will consume some manpower. For the staff engaged in garbage classification, their physical health may also be at risk. Huawei provides the acceleration module for Atlas 200 AI. At the same time, it is combined with the resources of the public cloud network. Collaborated with some merchants to develop a vision-based solution for mechanical arm garbage decomposition. The Atlas 200 acceleration module is integrated into our mechanical control board that is used to identify the types of garbage and control the mechanical arm. Can significantly improve the efficiency of our garbage sorting and reduce labor costs. We can see the application of Atlas 200, enabling the transformation of industrial machinery from programming to learning. Solve the last-mile problem of industrial automation. We have turned the movements of the robotic arm into real-time control. Instead of pre-programming all actions in advance, it is a state like this. So, this is where we conclude our introduction to Huawei's artificial intelligence development strategy.